Hi, welcome to this tutorial, which is part 2 and the second rule of multiplication. It's really raising powers to powers. So let's consider something like 2 to the power of 3 all squared. Now if you remember, this power here is telling us to multiply the 2 cubed by itself twice. And from the first rule or law of multiplication, if the base is the same, we add the powers. So it's 2 to the power of 3 plus 3 is 6. And if we wanted the answer, it would be 64. So it would seem that if we multiply 3 by 2, we would get this 6 here. Now, let's interchange the powers and see what happens. So it's 2 squared to the power of 3. Again, that power of 3 there tells us to do what? To multiply 2 squared by itself 3 times. And the answer turns out to be the same. Again, 2 times 3 is 6. Let's bring in some algebra and see what happens. So suppose it's a to the power of 4 cubed. Based on our observations, we would expect the answer to be what? A to the power of what? 12. 4 times 3 is 12. Well, of course, this power here tells us to multiply a to the power of 4 by itself 3 times. And the result is correct. If you add 4 plus 4 plus 4, you will get 12. Interchange the powers, so it's a cubed to the power of 4. The power of 4 tells us to multiply a cubed by itself 4 times. And the result is a to the power of 12. 3 plus 3 plus 3 plus 3 is 12. And we can also see that 4 times 3 is 12, and 3 times 4, of course, is 12. So we can now generalize and say if we have a to the m raised to the power of n, we can interchange the powers if we wish, and sometimes it is convenient, but the final result is that you multiply the powers together, m times n, so it's mn. That's the rule, the second rule of multiplication. So for example, if you have y squared to the power of 8, what would the answer be? Y to the power of 2 times 8 is 16. Okay? Now let's bring in another element in it. Suppose a 2 creeps in, so we have something like 2a cubed to the power of 4. This 4 here is telling me to multiply the 2a cubed by itself 4 times. And there we are. Some people think that you'd multiply the 2 by the 4 to get 8. Of course, it's not correct. Now, since multiplication is commutative, we can do it in any order we like. So I'm going to look at those 2's being multiplied together. How many are there? There are 4 of them, so it's 2 to the power of 4, which we know is 16, but I'll come to that in a minute. And a cubed times a cubed times a cubed times a cubed will give us a to the power of 12. So the final answer is 16a to the power of 12. Now, let's just have a look at again to see where this 4 comes from. Well, the power of the 2 is a 1, and 1 times 4 will give me a 4. A cubed to the power of 4, 3 times 4 is 12. Okay? Now, there's some misconception. I'll just do one more on this one. Suppose it's 2 x to the power of 5 y squared cubed. The power of the 2 is 1. 1 times 3 is 3, so it's 2 to the power of 3. The x component is x to the power of 5 raised to the power of 3. 5 times 3 is 15. And the y squared to the power of 3, 2 times 3 is 6. Of course, if you were to write it out in full, which means multiplying what's inside the bracket by itself 3 times, you would also get the same result. But we're trying to look for quick ways to do it. So the final answer then is 8 x to the 15 y to the 6. And you can see the 8 here, 2 times 2 times 2, which was our 2 cubed, is 8, and the rest x to the power of 5 times x to the power of 5 times x to the power of 5 is x to the 15, and y squared times y squared times y squared is y to the power of 6. Okay? Now, what happens in some cases is people have a misconception. They think, for example, 3 squared plus 2 cubed, that we can raise to the power of 2, that we can multiply the powers. So they think the answer is 3 to the 4, that's 2 times 2, plus 2 to the power of 6, 3 times 2. And that's not true, because the answer to this bit on the right is 81, if you work it out, plus 64, which is 145. If you did work out 3 squared, you get 9, plus 2 cubed is 8, and that's 17 squared, which is 289. And there is a difference between the two. That's the correct one. So you cannot apply the rule we've been using to an addition. It has to be a single term, and it's a product, just like that. Okay? Last example, or rather before that, sorry. Suppose it's x plus y all squared. A lot of people think it's x squared plus y squared. That's a 1, that's a 1, we just multiply them, squaring each one. Well, of course it's not true, because if you expand the bracket out, it's a square bracket, and I'm doing it the quick way. It's x squared plus 2xy plus y squared, and that's different, so that's not true. Finally, a typical exam style question might be simplify x bracket 2 x to the negative a half, so I'm bringing a negative in, to the power of 4. We'll leave this x alone, and let's look at what's inside the brackets. That's 2 to the power of 1, and 1 times 4 is 4, so it's 2 to the power of 4. X to the minus a half raised to the power of 4, 4 lots of negative a half, or negative a half times 4 is negative 2. So you'd have x to the negative 2. Finally, 2 to the power of 4 is 16, x to the power of 1 times x to the minus 2, add the powers together, 1 added to minus 2 is negative 1. And that's the acceptable answer. Well, I hope you found that useful. Until the next one, take care.